Today we're exploring animated text effects inside of Three.js. Something that maybe looks like this, could look like this, or even simpler, just like this. But the three basic steps are load the font, set up the scene, and animate things. Let's get started. Here's the code. To load a font, we need a font loader. Import TTF loader. The font is in TTF format. TTF stands for true type font. Let's also import font, and that's from a font loader. Great. Imports are there. Let's go ahead and import those down here. Const loader is equal to a new TTF loader, and loader.load wow, way too much stuff. That's all going to be good, but 1 second, please. Console.log res. And res is short for response. So let's save that and check our console. We've got a response, and it looks like a font. Well, the font data anyway. The next step I want to do is all that stuff that GitHub Copilot had for me, which is const font equals a new font based on the response. And then I'm going to define these properties. I'm going to pass this into the font, the text geometry. It's going to have the font and then just all this stuff. This defines the look and feel of the text. Play around with this. Not going to do that in this video. Create the text geometry. Const text geo is equal to a new text geometry. I'm going to pass in the text, in this case just Three.js, but it could be anything, and then the properties. So, well, actually I need to compute the bounding box, apparently. Now, calculate the center offset. This will become important in a second, as you'll see. There's a standard material that's dark red. Let's make it more of an orange. Yeah. Now we're going to create the text mesh, which is just a mesh passing in that text geometry. Add it to the scene. Oh, I'm setting its position, so it's offset. I'll show you both without and with the offset. There's an error, or else I would see it. Text geometry is not defined. My bad. Let's import the text geometry like so. And while we're at it, get rid of this icosahedron. And we're not animating it anymore either. Save. Hey! Now it's kind of sticking out the side there, and it's clashing with my BG sphere. Let's apply that center offset. And it should be centered up nicely. Way, yay! Way, yay! Way, yay! Real quick, let's just change the font, just see what another font looks like. I have one called Miso in here. Computer. Chakra patch. Let's do two things. Slightly darken this up. I just drop the intensity of the hemisphere light, and that darkens everything up. It doesn't affect the BG sphere because that's mesh standard material. The next thing I want to do is draw the lines that you see like that or that. So let's do that. I want to import a line 2 from the add-ons for Three.js. Unfortunately, just using the built-in line for 3 won't do. It doesn't give us enough control of the look of the lines. It only allows you to draw a 1 pixel width line, which is unfortunately not good enough. So let's import this add-on. We need a line material, a line geometry, and then a line 2, like that. Let's just tidy that up. And now we're going to instantiate all of those guys and use that loaded font data. Right here below where I'm adding the text mesh to the scene, I'm going to create a group to hold all the strokes. One stroke for each of the letters and the holes and the letters that have holes. I'll create a new line material, just really basic, white with a line width of 3. And now I'm going to get the shapes from the font based on this message, which isn't defined. It will be in a second. And I'm going to loop over those shapes. For each shape, I want to get the points for that shape. Now I need to do a little extra hand wavy stuff here. I need to provide a z coordinate for each one of those points because unfortunately it's just two-dimensional points. And that's because the line geometry needs 3D points, not 2D points. So I'm going to set the positions with 3D points that I just created. Now I'm calling this a stroke mesh, but it's just a line 2, and it's based on that material and that geometry. I'm going to compute the line distances. I'll show you why that's important in a second. And add it to my stroke group, which is containing all the strokes, and then add that to the scene. I don't think we're going to see it. The reason we can't see it is because of how it's placed. To illustrate that, I want to change the material. Here, I'm going to make this a wireframe. Wireframe is true. And we should be able to see the stroke. And we can't. Is there an error? Yeah, I forgot to change that. I think I'll leave this wireframe for a second because that's kind of cool. And make this mesh basic. Now it's a wireframe. This message needs to be defined. Okay, there it is. But the placement is off. You remember how to fix that from above? I calculated the center offset. So let's just set that for the stroke group as well. I'll just copy this line. And then replace text mesh with stroke group. And that should fix that. Its placement is off though. It's like kind of in the middle or the middle back of the text. So let's move it forward. Stroke group, hang on, let's do it here. Dot position z is equal to 1.0, maybe? I think that's too far forward. How about 0.2? I bet that's about right. That is just right for me. And I'm going to turn off the wireframe for that guy for the text geometry, even though it's cool. And that's that. Turn this back to a mesh standard. Yeah. Okay. See the problem? There's holes that are missing, and we can fix that. We'll check to see if the shape has holes. If it does, loop over each one of those and do what we did above. We're just going to grab the points, create 3D points, and stoke our line geometry positions with those points. Create a mesh and add it to our stroke group. Whoops, not Z. Save. And there we have holes now. Yay! The last thing to do is to animate these lines. To do that, I'm going to add an update method to each stroke. Let's define it right here. Oh, I wanted to show the compute line distances. Actually, it's not going to matter until we're animating things. I'll show you once we're animating. Stroke mesh dot user data dot update is equal to this method with an arrow function. I love arrow functions. No, that's not what I want. I am actually going to set the dash size and stuff like that. Here we define this line material. It's important if we want to animate it to say that it's dashed. Oh, I want it to be true. Okay, and then there's a couple of other properties we can set. We can set a dash size and a gap size, as well as an offset. Whoops, I think I need a comma here to get GitHub Copilot happy. Dash, I'll just write that in for you. Dash offset. And we'll make that 0.0 for now. So these additional properties go into the line material. Now that it's dashed, I can animate these values. Let's just animate the dash offset and see how that looks. So we'll say stroke mesh.material.dash offset. That's great. I already have this named line material. I think it's slightly shorter to write that. And save it. And nothing should happen. You can see the dashes though. Let's call in our animate method. Where is our animate method? Is it above? It is. It's above. It's up here. Why is it above? I like to keep it below. Below all of this stuff here. I think that's the, oh, I know why it's above. Because that's all of this is in that load method. Ideally, we'd refactor this so it's more clear. This is just kind of rough and dirty. What are we calling this? Stroke group dot user data dot update, and then pass in t. As you recall, every request animationed function gets a timestamp, so I'm just giving it a default value here and then passing it, and that's going to update with every frame. I think it's equivalent to milliseconds. Great. Now I'm calling this stroke group dot, but that's going to break it because I haven't defined that yet. The stroke group needs this update method. Stroke group dot user data dot update equals that, and then I'm just going to loop over its children. Stroke group dot children dot for each child user data dot update. Yeah, like that. And now this will still fail because not all of the children have update methods. Oh, stroke group is defined. Hang on. Because this is all inside this load method, it's a closure, and this animate method can't see this stroke group. Not only that, but I'm calling the animate method too soon. I'm calling it here before I've loaded the font. Instead, after I've loaded the font, let's call it then animate. Like that. This is just so you know, inside this load handler. Again, I'll try to make it clear at the end. I just wanted to get this up and running first. So save it. It's still going to error. Or actually, it's not going to error anymore. It's only just going to call it once. That's interesting. Did it just call it once? Why did it just call it once? Who cares? Stroke group. Here, let's define the stroke group outside the scope of this load method. Oh no, it has to be let stroke group. Like that. And oh, now that's what I was talking about earlier. I only created an update method for the strokes, not the holes. I could just add this to the holes as well. Let's do that. Right below where I define the stroke mesh, I give it a user data method. And it's line material. Yeah. You know why this works? And you know why I don't have to do this? For the holes, I'm reusing this line material. It's defined up here for the shape. That is the primary shape of the letter. And for the characters that have holes, like E, in this case, I'm just reusing that. So I don't need to redefine that update method, but I do need to say, hey, do you have an update method? Having that question mark at the end of the method call says only call this if it exists. If I hit save, I get that. It's horrible. Times 0.002. That should be a lot smaller. That's basically it. It's up to you now to play with things like how the dash is offset, how long the dash is, how long the gaps are, which letters are animated and which aren't. Change the material. Like I had this beautiful semi-transparent material. Let's add that. Instead of a mesh basic material on the mesh, I'm going to say a mesh physical material. And that allows us to define, if I just save it, it's probably really boring. But that allows us to, instead of just a color property, we can add a bunch of other properties. Roughness, transmission, the transparency, I don't care about the side. There's another property I wanted to add. In addition to roughness, transmission, and transparent, I want a thickness as well. Let's save that. See how it looks. Oh, see how it's kind of twinkly? If I turn the roughness down to 0, it's not going to be twinkly. It's just going to be kind of reflective. See, the lines are kind of doubled up now. I don't think that's a great look. Adding a little bit of roughness gives it a lighting effect. Let's change the length of these. Hang on, where is it? The strokes down here. These dash sizes. To do that, we have to do a little bit of extra legwork, but I think it's going to be worth it. Oh yeah, I wanted to show what happens if you don't compute the line distances. Yeah, so that's why you want to compute the line distances. Instead of getting a nice animation, the whole thing just pops on and off. All right. So for a better effect, I'm going to get this length. I'm going to calculate this total dist property. Let's see, let total dist. Now I can set the dash size and the gap size and the dash offset based on that distance. Excuse me. 1 second. Here, grab the line material and let's start out just setting it to this total distance instead of 0.1. Ooh, it's really slow. Speed it up 10 times. Pretty good, right? See how it draws the whole thing and then undraws the whole thing because we're using the distance. If I wanted to draw the whole thing and then stay there for a second, I can do that too. By increasing the dash size, I'll just multiply this by 1.5. Now it'll draw on and wait a second and then draw off. You could do the same for the draw off. Extend that a little bit and just speed this up a little bit. Oh, so cool. Experiment with different colors, different fonts. Let's pull in that Ken pixel again. Ken pixel, and then shrink it down a little bit. Just see how that looks. Interesting. Not what I expected. Oh, I wonder why the shapes aren't getting that. They aren't when I define the text geo. Isn't that interesting? When I set the size to something besides 1, the shapes are no longer aligned. I'm not sure what to do about that. I could scale down the entire stroke group. That seems kind of crappy though. Let's try it. Stroke, it's crappy, but let's do it anyway. Stroke group dot scale dot set scalar 0.75. This seems hacky. This is not recommended. It works like a charm though. Play with the line width. Let's make it 10. Oh gosh. Look at those fat lines. Isn't that cool? It looks like for the Ken Pixel font, we've got a lot more shapes. Like the S has 5 different shapes. Isn't that interesting? Let's change another font. Let's change it to computer. Where am I loading it? Here. Computer. See how that looks. Pretty cool. I'm going to jack it back up to 1. And this, remove that. Save. Let's reduce the line width too from 10 down to 3. Where is that? Here. Or 4. That's it for today. If you like this video and you know someone else who might like it too, please share it with them. It really helps my channel grow. Consider supporting me on Patreon. It takes a while to make these videos and your support helps a lot. Thanks so much for tuning in, and I'll see you next time.